Good morning children, how are you all? In today's session, we will be learning an interesting and important topic of light. Previously, you have learnt about an important phenomenon of light called reflection of light. So, today's topic is refraction of light at plane surfaces. It is a common phenomenon that when a pen is put in a tumbler filled with water, it appears to be broken. It is our common observation in the morning during the sunrise that sun appears brighter, big, elongated. Why? Similarly, sun appears bright, big during sunset. Why does it happen? Look at this duck. That duck is swimming in a pool of water. The upper portion of duck we can see normally, whereas the lower portion of the duck which is immersed in water is seen distorted. Why does this happen? Look at this. Observe the object through the glass. How does it appear? It appears elongated. Why is it so? Children, now observe this video carefully. Now we have a opaque bowl, a coin and a glass of water. Now let us put this coin at the basin of the opaque bowl. Now move back so that the coin just disappears. Pour the glass of water into the bowl and observe carefully. Now we are able to see the coin. Why does this happen? Standing at the same place, we are able to see the coin clearly. Earlier we were not able to see it. Now when we have poured a glass of water, we are able to see the coin clearly. Children, out of all these observations, there is a principle underlying. This is an important concept of physics. Now let us observe this coin experiment once again. Now in this coin application, the rays from the coin are passing through the air medium and we see the coin. But when water is poured in the glass tumbler, the coin appears to be lifted. It is raised to a particular level. This appearing of the lifting of the coin is because of the principle of refraction. Before understanding the concept of refraction, let us look into the fundamental principles and a few technical terms. The first basic principle of light is Fermat's principle of least time. Fermat's principle of least time says that a light ray always travels between 2 points in a path which needs the shortest possible time to cover. Now let us understand this with a good example. Observe this video carefully. The car is moving in a highway, that is the shortest possible path, but due to traffic it has slowed down and it is not able to move at a faster speed. But when it takes a long route, since there is no traffic, it is moving at a faster speed and it is able to reach the destination within a short time. So instead of taking the shortest path, it is better to take the path with shortest time. So this is Fermat's principle. This analogy is applied even to light. Light, when it travels, it does not take the shortest path, it takes the shortest time path to reach the destination. Now let us understand another important technical term called optically denser medium. A medium A is said to be optically denser than medium B if speed of light in A is less than speed of light in B. That is, speed of light in A is less than speed of light in B. Similarly, let us understand what is optically rarer medium. Medium A is said to be optically rarer than medium B if speed of light in A is more than speed of light in B. That is mathematical representation, speed of light in A is greater than speed of light in B. Then the medium is said to be optically rarer medium. Thus, medium A is optically denser than medium B if speed of light in A is less than speed of light in B. That is, optically denser medium is a slower medium. Medium A is said to be optically rarer than medium B if speed of light in A is greater than speed of light in B. Thus, medium A, which is optically rarer, is a faster medium. Therefore, optically denser medium has atoms and molecules closely packed, and thus speed of light in such a medium decreases. Hence, it is a slower medium. Optically rarer medium in comparison has atoms and molecules loosely packed, and thus speed of light in such a medium does not decrease comparatively. Hence, it is termed as faster medium. Now, let us look at this atoms arrangement. Light ray travelling through atoms in the denser medium gets observed and re-emitted at each atom location. Hence, the speed of light ray is slowed down. Look at the light ray. It is passing through all atoms. As it passes, the light ray is observed at each atomic location and it is re-emitted. So, in this process, the speed of light decreases. Let us look at a rarer medium. Light ray travelling through atoms in the rarer medium gets observed and re-emitted at each atom location. But as there are less number of atoms, the speed of light ray is not slowed. Thus, the light ray passes easily at a faster speed. So, children, with these concepts in mind, Fermat's principle of least time and optically denser medium and optically rarer medium, we define what is called as the phenomenon of refraction. Refraction, the process of changing speed at an interface when light travels from one medium to another medium, resulting in a change in the direction of light, is called refraction. So, when light travels from one medium to another medium, what is the important thing that is happening? There is a change in the direction of light. So, this is called refraction. So, let us look at this glass slab. Refraction of light is bending of light rays at the interface of two media. The two media here are air and glass slab. The rarer medium here is air and the denser medium is glass. When the incident ray that is passing through air interfaces at the boundary of the glass slab, it has slowed down because it is a denser medium, and because of this there is bending of the light ray, and this is called refraction. Now, look at this. When light ray travels from rarer to denser medium, it moves towards the normal. The incident ray, it is passing from rarer medium to denser medium. At the interface, bending occurs and the refracted ray moves towards the normal. And in the second case, when the light ray moves from denser medium to rarer medium, it moves away from the normal. The incident ray, it is passing through the denser medium, and at the interface it suffers a refraction and it is moving away from the normal. Why is it difficult to shoot a fish swimming in water? Look at this picture. There are two media, air and water. Here air is a rarer medium. that is a faster medium, that is speed of light is more in air, and water is a denser medium, that is speed of light is less, it is a slower medium. When a ray of light passes from the man into air then into water, at the interface the light ray bends as the light ray travels from air to water because of the difference in the speed of light. So, because of this it is difficult to shoot a fish swimming in water. Now children, you might have had a better idea of refraction. Let us understand in depth about how refraction happens. Observe this video carefully. Now we have done a small activity. There are two media as you see, the floor and the white cement. When the toy car is moving perpendicular to the interface, you might have observed that it is going undeviated. It is not bent, it is going in a straight line. Observe once again, it is moving in a straight path, but it has slowed down. When the toy car enters at an angle, what has happened? You have seen that the toy car turns in the white cement media. So, this is exactly what happens in refraction. So, to have a better understanding, let us look at another video. Light in the vacuum is emitted and it is moving at a faster rate in the straight lines. The light speed is around 3 lakh kilometers per second and it moves in straight lines. Light, when it moves in different media, it has different speeds. As we see, when light is moving in the glass slab, its speed is 2 lakh kilometers per second. When it is moving in water, its speed is 2,25,000 kilometers per second. Observe this, when light is travelling perpendicular to the surface, it goes undeviated as we have seen in the car. The light has slowed down in the medium, but it is going undeviated because it is going perpendicular to the interface. But when light is travelling at an angle, it goes slow and in addition it is bent. This is called refraction. Let us once again analyze this. See, when light enters from faster medium to slower medium, light goes as it is till the interface. Now, when the light travels, first the bottom part of incoming ray reaches the slow medium first and it is slowed down first at the interface, and this is the reason for rotating the ray towards the normal line. Later the top part of the light ray meets the interface and it also slows down, and this continues, and in the slower medium, that is the denser medium, the light ray travels with less speed and it is in a bent direction and it is bent towards the normal. Children, now is it clear for you why light ray is bent at the interface of two media? Now observe this video carefully. As we have said, light possesses different speeds in different media. For example, in vacuum the speed of light is 3 lakh kilometers per second. In water the speed of light is 2,25,000 kilometers per second. In glass the speed of light is 2 lakh kilometers per second. In diamond the speed of light is 1,25,000 kilometers per second. Now let us coin another important term called refractive index. The refractive index of glass is 1.33. How do we define refractive index? Refractive index is the ratio of speed of light in vacuum by speed of light in the glass slab. Speed of light in vacuum is 3 lakh kilometers per second divided by speed of light in glass, that is 2,25,000 kilometers per second. It amounts to be 1.33. So, the refractive index of glass slab is 1.333. In contrast, the refractive index of air medium is 1.0003. See, when the incident ray from air travels through glass, the ray is bent towards the normal. From glass, when it is traveling to air, glass is a denser medium and air is a rarer medium. When the light ray passes from glass to air, first what happens is the top portion of the incident ray comes in contact with the rarer medium air and it gains more speed, whereas the bottom portion of the incident ray has lesser speed as it is in glass medium. Because of this, the light ray is moving away from the normal. That is why we say that when light ray travels from rarer medium to denser medium, it bends towards normal. When light ray passes from denser medium to rarer medium, it travels away from the normal. Now children, you might have understood how does light ray travel when it passes from denser medium to rarer medium and from rarer medium to denser medium. This causes refraction. Refraction is all because of the difference in the velocities of light when it travels through different medium, and because of this we have a new term called refractive index. Refractive index is the ratio of speed of light in vacuum by speed of light in the particular medium. Absolute refractive index is represented by the letter small n, speed of light in vacuum is represented by letter small c, and speed of light in medium is represented by the letter small v. So, n is equal to c by v. Refractive index n is a dimensionless quantity as it is ratio of speeds in different media. Refractive index of a medium depends on the nature of the material and the wavelength of light used. Another important term is relative refractive index. Relative refractive index or the refractive index of a medium with respect to another medium is defined as the ratio of speed of light in first medium to the speed of light in second medium, or relative refractive index is equal to n to 1 is equal to refractive index of second medium by refractive index of first medium. Now children, after learning what is refractive index and what is relative refractive index, we will do a small activity to study the angle of incidence, angle of refraction and calculate refractive index. Let us do this activity. Let us take a white paper and let us draw the horizontal line and vertical line. At the intersection of these horizontal and vertical lines, place a semicircular glass slab and mark the angles. Now, focus a laser light. When laser light is passing through the normal, it goes undeviated. But when the laser light is put at an angle, then there is refraction suffered. Let us see once again. This is the normal, this is the incident ray, the angle between the normal and the incident ray is called angle of incidence. Now, here you see this is the refracted ray. Can you observe through the glass slab? This is the refracted ray. The angle between the normal and the refracted ray is called angle of refraction. This angle measured is called angle of refraction. Now, see, when the angle of incidence is 45 degrees, the angle of refraction is 29 degrees. So, measure all the angles of incidence. At different angles of incidence, you have different angles of refraction. So, tabulate the recordings for each angle of incidence, measure the angle of refraction and record it in a table. And from this we can calculate the ratio of sin I and sin R. So, sin I is the ratio of opposite side to the hypotenuse and sin R is the ratio of opposite side to hypotenuse in the refracted medium. So, let us look at Snell's law. Snell's law gives the relation between angle of incidence and angle of refraction. So, refractive index n 2 1 is equal to sin I by sin r, where I is the angle of incidence and r is the angle of refraction. From the activities we have done to measure the angle of refraction for each angle of incidence can be tabulated as we see here. Angle of incidence I, if it is 15 degrees, it is observed in the experiment that angle of refraction r is 10 degrees. And when sin I and sin r are calculated, they are observed to be as displayed in the table. So, the ratio of sin I by sin r gives the refractive index of the glass slab what we have used. So, as you see, for the various values of angle of incidence, there are different values of angle of refraction and the ratio of sin I and sin r appears to be constant. So, children, today you have learnt about the concept of refraction. Let us recapitulate what we have learnt. We have learnt Fermat's principle of least time. Next, we have learnt about optically denser and optically rarer media, and we have learnt the important concept of refraction, and we have learnt why refractive index is different for different media. And based on this, we have learnt what is Snell's law, and we have learnt the relevance of all these concepts in nature. So, children, I think today you have gained a better knowledge of the phenomenon of refraction. In the next session, we will be learning another important concept. Thank you.